My name is Andrea Brunacci, and I'm working for Pharma Technology already for quite a lot of time. This is my third seminar in Istanbul, so I'm proud to be here. The first seminar we spoke about the dusting, metal detector, and IPC. The second, last year or 2019, we discussed about the containment in pharmaceutical and actually in our segment. So after the double press of capsule filler. And today we talk about, instead of removing dust, we actually talk about the opposite. We talk about inserting dust in your double press. So we talk about external lubrication system, so mainly magnesium stearate, or talc, whatever it's used by you. We have 30 minutes, so I will not focus a lot on the description of the company because many of you knows we are a Belgian company based in the surrounding of Brussels. 85 people, it's fully family-owned. A branch in New Jersey following the North American market, and a branch in Hong Kong following the Asia-Pacific market. We do about 450 machines per year, so far away the leader in the segment. With a turnover of roughly 25 million euro. So what will be the topic of today? The topic of today will be the iSpray, our new external lubrication system. So recently Pharma Technology developed new machineries around the core business of the dusting and metal detector. One is an external lubrication system. The second one is a sorting machine for a packaging division. And then we have implemented a new division, an inspection division called Q Control, where my colleague Sven will talk about later for an inspection, few type of inspection on the tablet itself. So today we will talk about why do I need an external lubrication system? What are the benefits of the iSpray itself comparing to competition, let's say, unnamed competition. We will see about the customization integration with the press, because we believe we have designed a machine which is easy to integrate with existing press, so you don't have to think about the machine only for new project, but for existing press as well. We will see the principle of application. Then I think the more important parts will be the analytical test. So we will tackle the machine from the R&D point of view, and then a case study. So we are here with the Korsch guys, and they decide to make a test with our machine and competitors in an XL400 press, and we will see what data came out from that test. So why do I need an external lubrication system? So I'm sure many of you already knows, but when I have capping issue, I cannot solve with everything I tried with my tooling. Sticky product like effervescent, but not only. This is just an example. Reducing ejection force. So some product, they have a very high ejection force. Your press keep going in alarm. You have side stripes on your tablets, and that's one of the points that we are going to solve with the iSpray, with the external lubrication system. But while the first two do not require any modification in your press, the third one could require, not could, but must have a pull-down cam. So it's a different type of cam for the press. It's a cam that keep the lower punch, that pull the lower punch lower a little bit earlier, in the way that in the point where we are spraying, we are able to spray in the upper punch, lower punch, but also inside the die. If you don't have the pull-down cam, you will not see the reduction of the force with the machine, because the point where we spray, the lower punch will be already almost in ejection mode. We will see later in a couple of slides. And then the continuous manufacturing. The continuous manufacturing looks like a little trend going on now. So to avoid the blending stage, to avoid an extra point of adding magnesium stearate in the receipt, in the blending, then we can spray directly in your press. What are the key benefits? So I have highlighted some of them. I will not go through all of them, but just Few of them, so we speak about the continuous control of lubricant, tank to flow sensor. So when we were developing this 4 years ago, we made some tests with a company manufacturing a very sticky product. They removed from the blending the magnesio stearate. At that time, it was just a prototype. We didn't have a flow sensor. Keep in mind, the flow sensor is a unique selling point of the machine. The competition doesn't have. So what happened is that because of the magnesio stearate tends to bridge a lot, is very volatile and very sensitive to statics. What happens is that for a few seconds we didn't spray because there was a jam inside the tube. So it was enough few seconds for the table press to get stuck with the sticky product and 3 hours to clean. So production gone. So we added then the flow sensor. So when the sensor see that the flow is reduced, we stop the press, which means there is something going on. Another unique selling point is the integrated vacuum system. So it's very important. I see a lot of customers recently that they have a normal, we call normal standard external lubrication system, that they have put the external lubrication system aside because they cannot work with that. They have long batches, but after 2 hours, they have to stop the production, they have to clean the press, and it's something that efficiency, productivity, and quality, they don't go along together. So the vacuum unit here that you see, it's integrated in the machine. We control the under pressure. It's not using a turbine like a normal vacuum system, but is using a reverse venturi, which is creating a much higher under pressure. This allowed us to spray precisely and without having wasted magnesio stearate inside your press. This is another point we will look later in the details. The backup line. So now you see here a machine. This was designed for a double side press, but instead of 2 lines, you see 4 lines. Why? The reason is simple. So we use actually when we spray only 1 line, but we monitor from the HMI the pressure on that line. When the pressure starts dropping, it means that you somehow have a kind of jam inside the line. So automatically, without need to stop anything in the process, we move from line A to line B, and the operator has the time to remove the line, clean, put back in place. It takes approximately 5 minutes to clean everything, and then it's a loop that doesn't stop. So we move from one line to the other. Maybe one line, if you are unlucky, normal process with 1 line is few hours, so you have enough time to clean the previous line. The last 2 points are related to the quantity of the magnesium that you spray. You see here there is 0.1% of the nominal weight. This is something you have to keep in mind. It is a very important result because for different regulation, FDA or European Pharmacopoeia, if you are able to stay below that line, there is a kind of advantages in the registration of in the re-registration of the product. And last but not least, the complete CFR 21 Part 11 compliant machine, which again, it's a unique selling point. Let's go into details of the integration with the press of the machine. You see here 3 different spray nozzles. So you have different level of integration with the press. The last one is simply one press piece where we have worked together with the press manufacturer to integrate the spray nozzle. But the other 2 are the standard one, and depending on the space that you have between the Philomatic, so the feeding of the system, and whatever it's the block that is before, you can use a bigger one or a smaller one. The integration is quite easy with every type of presses. Normally, it's not requested a table press supplier to do that. We can do that easily. We just have to design this piece, which you call the bracket, the holding bracket, to keep in place between the upper punch and the die table, to keep the between them to keep the nozzle. The space that you see here it's what is spraying, so the spraying point, and it's up and down, and immediately here there's a suction. This width, it's depends on your tablet. So you have big tablets, you have 25 mils tablets, it's gonna be a big one. You have a small one, you're gonna be a small one. So you see here a kind of integration into a 3090 press from Fette. So you have the feeding system, the reject, and here there is a little space where we were able to integrate the iSpray and spray nozzle. So in that point, you have the feeding, you have the pre-feeding, so you have the dye which is ready to get the powder, and that's the point where we spray. So we coat upper punch, lower punch, and the walls of the dye. So in the little video here, you see, maybe you remember the spray nozzle that I was showing in 2 slides before. Look at the arc here. So this arc is magnesium stearate. So it's the pulverization of the magnesium stearate to coat your system. You see? So when I was mentioning about not having the cloud of magnesium stearate inside the press, it's exactly this. So having an aspiration and a special design and a control of the aspiration, because a lot of customers are using the aspiration that it's normally given to the table press, just with a Y connection, which goes to the deduster, which goes to the external lubrication system, and the under pressure that you get here is nothing. So having the aspiration on board and having a special design allowed to have this little arc, which is doing the job perfectly, but it's not wasting the magnesium stearate around your table press. So that was a little bit the principle for application and the place where we spray. And we now speak more about we tackle the machine from the R&D point of view, so the analytical test. So why we performed the test? We performed the test to analyze actually 4 main points. So the first was we wanted to see the influence of the magnesium stearate on the ejection force of the press. That will be clear in the case study where we see the graph coming from the press of Korsch. So how do we run a test? We normally start with spraying a lot of magnesium stearate, so quite like 16 grams per minute I would consider a lot. And then we go down until we find the point where we could start seeing some issue. And that normally starts with thickness, or could be that you see the ejection force which is raising. So doing that, we look for the ejection force to remain stable, and the physical parameter of the tablet also remains stable. When I say physical parameter, I mean the diameter, the weight, the thickness, and the diameter, weight, thickness, and hardness. Then we have the third point, which I believe maybe is the most important for many of you. Once we have found the right spraying rate for the iSpray, and we keep doing a test, like a production test for 4 hours, then we create a little batch for a customer, and the customer has got to do his homework, like analyzing the quantity of magnesium stearate that we were adding. So it's very important for the customer itself to know how much magnesium stearate the machine has added into the formulation. The last point, instead, on the opposite, is merely for production, and it's how clean is my press after 4 hours of run. So we're going to see those 4 points into 2 different tests, same test, 2 different types of tablets. The first one was 13 millimeter, quite a normal tablet of tabletos, 3.65 thickness and 600 millimeter weight. Was compressed at 55 Newton, The lubricant was magnesium stearate, and we were running at about 100,000 tubs per hour. So what we could see from the beginning is, you look at the pink box here on the right. So this is the speed of the screw that is feeding the magnesium stearate. So you can see from the box next to that higher speed means higher quantity of magnesium stearate. So if I now link the green box on the left and the pink on the right, you see that when I have higher speed of, and so higher quantity of magnesium, I have lower ejection force from the press. If I decrease my speed, I decrease the quantity of magnesium and I increase the ejection force. So this is a sign that the product is a sticky product. So in this situation, the customer, of this specific test, the customer agreed that the perfect ejection force for them was about 700 Newton meter. So 700 Newton meter was corresponding to 1.44 gram per minute, which is very, very little quantity of magnesium stearate. And the 7% was the speed. So if I look at the chart, I had 270 minutes of run. So my goal, if you remember, on the point number 2 was to check that the ejection force was stable in the entire period and the physical parameter of the tablets were also not changing. So as I see here, the ejection force goes between 780 to 750, so remain very, very stable. And if I go to check the thickness, the hardness, and the weight, I see that we are very, very stable in the entire run. So for doing that, we used our own P tester. So the second test was physical parameter, ejection force stable, 4-hour run, after finding the right ejection force, and that was what it was matched. Then you have your homework. So then the customer went back to the university or went back to the laboratory and made the analysis of how much magnesium stearate per tablet. So they took out the tablet sampling from the batch. And as you see here, again, very, very stable. And we talk about 0.022% of the nominal weight. So if you remember, from the second or the third slide, I was mentioning 0.1%. So here we are much lower than that. So the range is 5 times lower. What we can also say is that in 4-hour 30, you see that the graph is very stable. If I look at the other competition, what they tend to do, they tend to start quite stable and then they end up very high. Then the last point for this test was the number 4 was the production test, was how can I compare the machine with something that after 2 hours I have to stop and clean. Is that clean enough? So what we did, we checked the unvacuumed magnesium stearate. So you see the majority, but far away, the majority of the magnesium stearate is vacuum back. So what you have in your press, considering the one that it stays in the punches in the die, it's really nothing. So if I look at the spray rate of 2 grams per minute, I have a total amount of 120 grams sprayed, and the one unvacuum is only 3 grams. So 3 grams is on 120 is what is left in your press. Not in your press around, but in your press around plus the one that you need, so punches and die. So of course, if I go to 6.5 grams per minute, which is normally what we spray for a big effervescent tablet, then I have higher quantity. But still, we speak about 5% of what I have sprayed. So the machine will have almost no difference in terms of powder, residual powder in the double press, you will have almost no difference between working or not working with an external lubrication system. And the one of you that used to work with an external lubrication system know that this has always been a critical factor. Last part of the presentation, so I have 10 minutes left, is about the case study. So the test between competition and the iSpray was done in Berlin with Korsch. So the objective of the test was, first of all, was to make the integration, to see how easy was the integration with an XL400. The installation, so you will see the drawings, the picture of the two systems, and see the layout, the footprint, the fact of the aspiration on board. We were monitoring rejection force for the entire time. And the spray mode and impact on the press, and this is the last point that I'm mentioning, but also the spraying mode. So you will see two different feeding systems, two different way of spraying the magnesium. The audit trails, which the other one rely on the press, while we have our own standalone system. And last, the disassemble and clean. There's a little video where our technical director is disassembling the machine without tools in a few minutes. So let's go one by one. So easy integration. So this is a turret for an XL400. This is a pump part which was designed by our friends from Korsch. You see the feeding system. This is the block of the reject system. So the integration was very easy. If you look from, this is our spray nozzle, the spray nozzle that we used. So one channel is for the for the magnesium sterate, and the second channel is the aspiration. If you look, so this picture is taken from this side. This is the die table, the upper punch, and that's the position of the spray nozzle. The easiness of installation allows us to test the machine with all the customers. So if you have a potential project, if you want to replace what you have already, if you want to test because you have difficulty manufacturing, the easiness of integration allows us to send the machine to you, come and make the test together. Let's speak about the footprint. So, well, what I'm seeing now is our competitors on this high-level machine. So, look, the vacuum system is something they don't have. So it's a separate unit. You have cable around. There is no integration. The simple HMI, which just start and stop and no more function. And that's the iSpray version for single side. So backup line as well, but single side press with on board the aspiration. What you see here, there is also a pneumatic valve, so the machine doesn't have to be stopped when the tank of the or reservoir of the magnesium sterate vacuum bag is full. It automatically close the valve, the operator change, put it back in place, and then you start again. So having the inbuilt and continuously monitor under pressure of the vacuum system is one of our key points. And if we speak about footprint, we are roughly 40% smaller than competition. Let's see what we have manufactured together with Korsch. We spoke about to make something which was quite difficult to manufacture. So we decided for dextrose, 90% of dextrose, which is known to have a very high ejection force. The lubricant was magnesium sterate, and we fixed a spraying rate just to have the same condition for both machines. So we decided 3 grams per minute was the right spraying rate. So what I'm seeing here, I'm seeing the feeding system. So I'll start from the feeding. So On the left, you have the competition feeder. On the right, you have the iSpray feeder. And no, I should be able to show. Look, this is what we call cigarette ash effect. So what happened in their machine is that they actually have a kind of compacting stage before. So then when they go to feed, they have ashes effect. While the ashes effect will give peak, of course, because it will be sprayed in peak. While on situation of Pharma Technology, we have a pulverization. So fine powder allow you to spray constantly without having peaks. And that's the reason, one of the reasons, why if I go to look on the ejection force of, graph from the press, I see that they have huge peaks. Those huge peaks can be linked also with the type of feeding and the very unstable ejection force on the press. If I make a slow motion on the spraying, you will see that you will have situation where you have spraying, non-spraying, spraying, non-spraying. On the right, in our situation, we have a much more stable ejection force without peaks, almost no peak there. So what the ejection force comparison is telling me also, that I take two RPM, two low RPM, 10 and 20, same spraying rate. So with the same spraying rate to have no stickiness with the competition, and in I have 680 Newton and 920. Look, I have much lower ejection force at the same spraying rate with iSpray. What does it mean? Means that I need to have the same condition of the competition. I can spray much less magnesium stearate. Now, magnesium stearate is not so expensive, but spraying less is also mean that you have less magnesium in the tablet, residual that we don't want, and less in the tablet press. So with the same spraying rate, to achieve the same result, I can spray much lower quantity. Why I can do that? I can do that, as I explained from the beginning, as my topic was mainly because of the design of the spray nozzle and to have on board a special aspiration system. So reverse venturi, very high under pressure, always monitored. There's an automatic washback, which means that the machine itself, every 4 or 5 minutes, depending on the spraying rate, clean the filter. So you don't have to stop. You don't have to worry that after an hour of production, the aspiration level is decreased or the quality of the aspiration is decreased. It's because the machine, after 3, 4, 5 minutes, it is a setting depending on the spring, as a washback cycle where it cleans the filter before starting to make the aspiration again. The situation about the pulverization that I mentioned, look, the things that is left in the press is really very fine powder in the iSpray, and the granules that you see here on the competition is also telling you, and you can easily link to the graph of the ejection force. So that's one of the reasons why you don't have a stable ejection force, and that's why you will find tablets also with such a level of magnesium and tablet with such a level. While, as we saw from the graph with iSpray, we have a constant quantity. Well, there's the backup line, as I mentioned. So if you go pinching one of the tube just to test, you will see that as soon as decrease the pressure in the tube, the machine itself change into the second line. So you will avoid to have this situation. This situation is clear, and at this point, you have a blockage in your line. So immediately the ejection force goes up so high. So imagine that this point happen with the iSpray, then we switch on the second line. So you won't have this peak, and you won't have the press stopping because of the ejection force going too high. So the last two slides, and then I'm done, is regarding the CFR software. So we comes with an audit trail, is everything user-friendly, I must say, where you can select the receipt, where you can select the quantity of magnesium that you spray, that you validate. So everything is connectable with an Ethernet connection. We create a shared directory where you can enter and extract the report for your database. The last slide is about the cleaning, the cleanability and the disassembly of the machine. So the video speaks for itself. So the guy is able to disassemble the line and the backup line and the complete machine, or at least the part that needs to be cleaned, in about 2 minutes before going into a real cleaning.
So thank you very much for watching this video. I hope.
So that was, if you have any question, we are here the entire day, or you can always refer to Eileen from Tema.